Welcome everyone, and thanks. He made sure everyone is awake. Good afternoon. Welcome to this session on how Intuit moved to a new GraphQL gateway and handle the busiest time of the year. I am Rama Palaniappan. I'm a principal engineer from Intuit's API platform team. Let's talk about Intuit if anyone doesn't know about it. Intuit is a fintech company. We provide financial, accounting, and tax preparation softwares for two sets of groups. One is individuals or consumers, other is small businesses. Our flagship products include TurboTax, Credit Karma, QuickBooks, MailChimp, and few others. Okay. In this session, I'll cover GraphQL at Intuit, how it evolved over years, architecture of the new GraphQL gateway, and some key learnings out of it. GraphQL at Intuit. So before I get into it, I just explain, briefly tell what my team does. I'm from the API platform team. Our team's goal is to accelerate API development at Intuit. We do this by providing runtime infrastructure and some design time parts. At the runtime infrastructure, we provide highly scalable and resilient infrastructure with proper observability and all of those things. And at the design time, we provide tools, workflows, and processes that help all API stakeholders to make sure our goal to accelerate API development, whatever things that is required, we do those. Okay. Before I play the video, I'll just give some introduction here. Today, if an Intuit development team wants to create a new microservice with GraphQL API in it, they can do it in few clicks using the internal dev portal tool that you're seeing here. So this process will create GitHub repositories with GraphQL template code in it. CI/CD pipelines will be created for that. You'll have a Kubernetes deployment, and mock servers will also be created and hosted by our team based on the schema that the subgraph or the GraphQL schema of the microservices there. So let's see how it is. You go click create a service, and enter the service name and other details there, primarily which BU you are from. And you say, I need a GraphQL provider. So this will get you a Java template for it. And this will take some time. It won't be this fast here, so it'll take like a few minutes for you to get. So you'll get GitHub repositories, CI/CD pipelines with all the GraphQL. The CI/CD pipeline will be GraphQL aware. It'll have the linters and other stuff. So this is a schema that would be given in part of the template. The resolvers or the data fetchers for this, and some unit tests. And you could also get an API Explorer for this particular service that got created in the same dev portal experience. So this is just, we are talking only about the microservice with a GraphQL API till now. Yeah. Okay. So once the team gets this, what they do is they go replace the vendor template with the schema, with their own schema in it, and later add resolvers to it. Once that is done, they come back to the dev portal and, let me see. So they'll click on GraphQL schema composition, and click on a button that will say pending approval. It will create a workflow. In this case, we are using GitHub. So this is similar to what Apollo is now doing in the Apollo Studio as well. So you get to, this will be reviewed by API stewards. So they review the schema based on Intuit specific guidelines, as well as certain other things that we wanted to ensure the graph has properly there. Once that is done, they will approve it, and this will also create additional PR to the existing workflow with additional stuff that are related to the supergraph onboarding pieces. Okay, so this includes the schema composition checks, the schema linting, and the mock server. We'll also have mock server supergraph as well, so that you could check all those things without actually interacting with the real resolvers. And this also includes schema publish steps. Okay. So let's see some metrics for the GraphQL API ecosystem at Intuit. Most of Intuit's API traffic is REST, but we are steadily seeing GraphQL API traffic increasing. Today, we see around 90K requests per second for all GraphQL APIs at Intuit. And we have like 2K plus clients and 100 plus subgraphs. Okay. Before I get into the new GraphQL gateway and why we did that, it would be better if you could tell the evolution of GraphQL at Intuit through this timeline. In 2015, GraphQL was open sourced. During this time, one of our flagship product teams was revamping its API. And GraphQL was the right fit for them, and they adopted it, one of the early adopters. At the same time, they were also splitting their monoliths into microservices. So we ended up with having microservices with GraphQL APIs. The term subgraph may not be coined then, but we had them, and we required a unifying way for the clients to access these. So we required a GraphQL gateway. So what this team did was they built a gateway called Platform Abstraction Service, and they were able to run this. This is only within that particular flagship product team. Okay. GraphQL and the Platform Abstraction Service grew in popularity within Intuit, and many teams adopted it. So the moment it goes beyond a particular team or a business unit, there would be additional use cases that will come in, and the newer teams had found certain limitations with the way Platform Abstraction Service was registering the subgraph schemas, and they had their additional use cases. So what the other team built is they built another schema stitching gateway called Data API. So this was also popular within the other BU. There were a lot of teams that were using, creating or contributing things to this particular gateway as well. These two gateways are highly scalable and stood the test of time. Intuit's traffic is seasonal. A significant portion of Intuit's traffic is seasonal, as we are tax preparation software. So during the tax deadlines, you get a huge amount of traffic. So these two gateways stood that test of time. It was serving the need, whatever it was created for, but they had some issues as well. Like, since these were internal gateways, at times it lagged keeping up to the specs or industry standards. And the knowledge of these gateways was very limited to the team that created it. So if someone wants to onboard to it, so they had to either talk to the team, it was not self-serve, and they couldn't search anything on the internet about how to get things done. So at this time is what we started seeing Apollo Gateway as well in Intuit. So there were teams who are using Apollo Gateway as another gateway. So if you look at it, we had 3 different gateways merging subgraph schemas in 3 different ways. And so what happened is, it depends on which part of the organization within Intuit you are in, you tend to align to that particular gateway that was there, because you had some of your other related dependent systems are already contributing there. So if you are going to create, you would also want to contribute to it. So it was not a unified thing. So that's when we wanted to have we want to unify all the gateways. So it's a hard decision. So what we had done is, we collected a group of architects across Intuit and asked them to solve this problem. So then this mission team looked at all options at that point in time and ended up saying that we'll use Apollo Federation 2 as a spec to merge all the subgraph schemas. So that's what we had. The initial thing is the Federation 2 was a spec that was decided. Okay. Now let's go into the architecture side. So at Intuit, we deploy in Kubernetes, and we run heavily on AWS. Okay, so that's the context there. And so maybe just see if you could get. So this layer here, the orchestrator. So we call the GraphQL gateway as orchestrator, as it orchestrates the request across the subgraphs. And so the orchestrator is above the subgraphs, and it is behind Intuit API gateway. So Intuit API gateway is a common API gateway that serves all the REST gateway traffic as well. This is the ingress for all traffic into Intuit. So for GraphQL as well, we are going through this. So API gateway does the normal gateway related stuff like DDoS prevention, WAF rules, and it also does authentication for us. So it does those things. Even for GraphQL, we let the API gateway do that. And the orchestrator will have to talk to the schema registry. In our case, it was Apollo Studio, to get the schema. And once it gets the schema, it knows what all subgraphs it has to connect to at runtime. Okay, and the green boxes from a gateway layer, orchestrator, and all the subgraphs, these are Kubernetes namespaces. And these Kubernetes namespaces could be across different Kubernetes clusters as well. Okay, so the Kubernetes cluster, if it is different Kubernetes clusters, it is actually different AWS account at Intuit as well. So we have to make sure the connections, the communications are also good in there. So what we have is all these purple boxes that you see here. These are called Istio Envoy proxy. These are service mesh sidecar proxies. These are responsible for the communication between all the layers that you're seeing, including the cross-cluster communication. I'm just not going to go deep into service mesh, but we'll give you a very brief overview of what it is. Service mesh is a dedicated infrastructure that facilitates service-to-service communication. Mostly, if you have heard about east-west communication, this is what is. So we, at Intuit, we use Istio as a service mesh for us with Envoy sidecar proxies. So you could have multiple different variations of service meshes, but this is the one that we are using. And Istio, together with another open source product from Intuit called Admiral, is responsible for the cross-cluster communication between the GraphQL orchestrator and the subgraphs, or the GraphQL gateway and the subgraphs. Okay. Now we have a spec to merge the subgraph schema and an architecture. The next question is, how many supergraphs do we need to run? So it was a very hard decision for us. So what we decided was, we'll start with one on the unified gateway, whatever things that already we had 3 different gateways. We said the target state, we'll start with one, and we came up with these items to consider whenever we want to create a new supergraph. I'm not going to go through all of it. It's basically what you're saying is the target audience is like, who's going to consume it? Like as a client, who's going to consume it? So they shouldn't be hitting, one client shouldn't be hitting multiple endpoints. They should always be hitting one endpoint. That's the basic of GraphQL. So that's how you could get all those contents, whatever you want from one set. So primarily, based on the API consumer point of view, try to split it. And there could be some common entities. A subgraph could be required in 2 different supergraphs if you're going to have multiple of them. So you should support that as well. And there are things like categorization. So this is a little bit different. People would say, why are you doing it this way? This is basically, you may have a functional group or a business unit. So you don't want to have your supergraph based on that. But at times it would be important as well to consider this into account, basically because there could be more alignment towards that particular, within a particular business unit or that's also there. And deployment methodology is basically, if you want to avoid noisy neighbors, if you have different set of products, like there could be a peak for one particular product and one particular time. So you don't want that peak to impact others who are not at that peak. So there could be other considerations as well. So these are all things that we wanted to consider, but we started with one. But we had to make sure we could support multiple supergraphs. So the way we tried this out is using Apollo's contract feature. So at design time, all subgraph schema here, all subgraph schemas here will be tagging their types, basically. And we'll be publishing to one global supergraph schema within Intuit. So all of these, this is the normal way of publishing it. You just publish it here, and based on we'll filter this global supergraph schema based on these tags. We include certain tags or exclude certain tags and create the filtered schema called the contract supergraph schema here. So we could have multiple of them, like in this case, contract 1 supergraph schema has tags 1 and tag 2. So these tags 1 and 2 could come from any of these subgraphs, it doesn't matter. So because it's going to filter only from here, and all these are going to be merged into one supergraph. So all the naming conflicts and other stuff would be resolved at this point when you're publishing it, and then you could split based on this. So this approach gives us two advantages. One is like today, if subgraph 1 is in contract 1 supergraph, tomorrow if you want to move this in and make it available here, all we have to do is change in this area. So the publishing doesn't change. All you're doing is just the contract part, and the deployment also doesn't need to change as long as it should be there. So you just change it here. So this tag 1 could be moved here. Or you could have a way where you would want to have one subgraph be available in multiple supergraphs. So that's also possible with this option. So that's the way we would wanted to go with this. But this adds a lot of complexities and more surface area for schema conflicts. So we have to make sure we detect these schema conflicts as early as possible. So we don't want to, basically, if you're not checking for schema conflicts in all these contract supergraphs, so you may break something, because this publishing would work. This filter contract should also be checked as well. So you will have, you are increasing your surface area for schema conflicts. So we need to make sure those are all captured and at the CI/CD pipeline layer time itself, and you prevent it from going to all the way to production. Okay, at runtime, all these GraphQL orchestrator here, or the supergraph orchestrator, what it does is it gets the supergraph schema from the contract, not from the actual graph itself. So it just pulls it from there, and based on that, it knows what subgraph it has to connect at runtime. And we make sure that a client here goes to only one DNS endpoint. So it's not going to go to two different things, because otherwise there's no point in federation. So that's the overall thing. So this is how we are supporting multiple supergraphs. So that way, its naming conflicts are addressed at the time of publishing itself, so that you can move them later at any point in time. Okay. So before I tell why this picture is here, I'll tell you what it is. This is a 1860s inspired a general store in Old Town, San Diego. Old Town is called the birthplace of San Diego. It's under 5 miles from here. Do visit this place if you can. Okay. The reason why it's here is because of the name of the store. The GraphQL gateway that we chose is written in Rust programming language. So when we decided that we'll go with Federation 2, at that point in time, Apollo Gateway was the only gateway that supported Federation 2 spec and in GA. So that was our default choice. Okay. So I think, and another reason for that is like some of our internal teams was also already running Apollo Gateway. So we didn't look further. As I told you earlier, a significant portion of Intuit's traffic is seasonal. So we want this new GraphQL gateway to scale and handle the peak traffic. So we did our own benchmarking test for this. So what we found with Apollo Gateway was 2 issues. One is the number of requests that each instance can support is limited. But this could be remediated by running more number of instances to support the expected traffic throughput that we wanted. But the major issue that we saw was the variance in response time. So in this one, what we are doing is like we had a subgraph with 100 milliseconds response time. So we expected the gateway to add as minimal overhead to that 100 milliseconds, and we were expecting it to come fast. So it was working good till this point here, around like 40 requests per second. And this one gave all the way till around 70 requests per second is what the Apollo gateway did in this benchmark testing. But what happens is, from 40 onwards, the response time increased. It went all the way to 2.5 seconds, like from 100 milliseconds to 2,500 milliseconds. So this variance is something that we didn't want it, because when you're going to send all your requests through a common gateway, and if that gateway is increasing the response time at some point in time, that could have some domino effect later down the line, because each request is being held for that much particular time at the gateway layer. So this was the reason. This is when we started testing the same with a similar load, similar profile with Apollo router. And Apollo router didn't have this response time variance, and it checked all the boxes for us. So we decided we'll go with Apollo router as a GraphQL orchestrator, and we've been running in production for almost a year, say for more than a year now. So that's where we are. And I wouldn't say that we are done with it. So what we have done right now is we've identified router as a orchestrator and migrated all things that we're running in Apollo gateway over here. We still have to get things migrated from these two other gateways. So we are in the process of that. Hopefully we'll complete it sooner. Okay, so some key learnings here. So initially router was listening only on one port for both the incoming traffic as well as the metric. So as I told, we are running Istio's Envoy sidecar proxy. So the Istio proxy actually intercepts the traffic port, and that got into a lot of problems because Prometheus was not able to scrape the metrics from router. So we had to run a lot of workarounds. We ran another sidecar to make sure Prometheus can scrape this out. Thanks to Apollo's router team, they listened to us, then quickly fixed this one. So right now, you could run a router with one port for traffic, one for health check, one for metrics, and all of that stuff. And we had to do a lot more configurations on the Istio side as well. So by the default configuration that we had was not using HTTP2, so some of the things were missing. And max request, global traffic policy, and outlier detections are things that we had to tune for our needs. And customization. So we created Rust plugins for the first 3 items, the access logs, propagating response header, depth limit, and the next 2, the request header propagation and open telemetry with other things. Those are all configurations that we did. So right now you also get a basic query depth limit as part of the base router itself. So we are not using that depth limit plugin right now. So the only 2 plugins is what we are using. And we are using Rust plugins, not a sub-processor, because at that point in time, these were not available. And we are comfortable running Rust plugins, so it was okay with us. GraphQL gateway and subgraphs is a very good example of a distributed system. I think I've seen multiple talks as well on observability. So make sure appropriate observability is in place. You should be able to detect anomalies automatically, identify the failing layer or component without any confusion. Because if you are going to run or operate a GraphQL gateway at your company, you don't want to be sitting in every incident that happens in your company. So you need to make sure who's responsible for it, for the failure. So that should be easily identifiable. And whenever possible, automatically recover. So those are the things that I want to do. But I am not going deep into it because the kind of toolings that you use would be different. Make sure your metrics, traces, logs are captured whatever tool you are using, and you could do those 3 things. Detect and identify the failing layer and automatically fail over or recover wherever possible. Okay, so this is the last slide. So 4 things that I want you to take home from this talk is, first, choose a GraphQL gateway that is right for you, including the spec, federation spec or whatever spec that is required, the actual gateway, check the performance, do benchmarking yourself and see whether that works for your traffic profile. Second is GraphQL gateway doesn't run in a vacuum. Make sure your chosen gateway works with the tech that surrounds it. Okay, for us, it was Kubernetes and service mesh, but for you, it could be something else. Make sure that works around it. Third, make sure you can customize it. Because when we started off with it, we never thought that we would require a response header propagation back to the client. There would be always some sort of request that would come based on the use cases. So you make sure you can customize it at all layers. It could be at the service mesh layer or the router layer or any other layer that you're using. And fourth is operational excellence or observability. To be successful, you need to have this. Without this, it will be very hard to be successful. Okay, so this is a feedback for this session, and I'll hold it for a while if you want to pick. And if you need to contact me, you could check my LinkedIn profile, and I would be around. You could, if you have any questions, you could ask me as well. Thank you.